Okay, so hello everyone, welcome to today's session. Today we will be looking at one of the few models that we haven't checked, which is on the unsupervised learning part, and that is clustering. So what do we mean by clustering? So clustering, if we search the definition of clustering, you will see that it's putting things together, okay? Or if we derive the meaning of clustering from cluster, you can see it's a group of similar things or people positioned or occupying closely together. So if I was to draw something here, an illustration of how clustering works. So let's say I create a new drawing here, then I can illustrate to you how clustering works. So just like the K neighbors model, and the decision tree and the random forest models, we have two ways in which we can cluster. So we can cluster using distance and we can cluster also using trees. And here we have the distance one. Okay, just give me a minute. So here we have the distance one. Okay. So let's say we had this box here, and in within that box we had, let's say, we had those circles, and apart from those circles we had these x's, okay, and apart from those x's, let's say we had something like these. Okay, so if I was to perform some kind of clustering, so what I will do is, first of all, I will check the shape of the item that we have in the data. And when I talk of shape, this means things like the size of the item, its appearance, so its outwards appearance. And I will see that here we have circles, here we have X's, and here we have a random shaped object. So this means that I will have group 1 here, I will have group 2 here, and I will have group 3. So that's the distance one. So the other one is the tree-based clustering. So for the tree-based, we come from the top and define some few things. So for example, here I can say something like size, I can say something like shape, and we can say something like color. So these are the different things we are looking at. And from these different inputs, we should come up with an output down here, maybe saying that this is a circle or a cross based on the inputs that we are getting up here. So this is tree based. Okay, so for the tree based, we can have something like this. So let's start with size. So we can say maybe the size is 40, or maybe let's say here 50. So if it is 40, then we check the shape. So is it round or cross? So if it is round, then we have these other class. So let's say class 3. Then if it is a cross, then we have class 1. Then we proceed on and define all those other stuffs that will help us group our data. So like create labels for our data set. So this is a model we call the K-means model. So this is how it works. And this is the other model that we have. And the other model that we have there is the hierarchical clustering. Okay. So it's a hierarchy. So it means it's starting from somewhere and we are having splits that come up with the final model output. Okay, so let's go through the theory part and see what's the detail that we have for each model. So k-means clustering. So k-means is a popular clustering algorithm used to classify a given set of n-dimensional points into k clusters. So the algorithm is based on the concept of minimizing the sum of squared distances between each point and the center of the clusters to which it belongs. So how do you create your k-means model? So you initialize a k-means model with k centroids randomly. So remember when we were creating a k neighbors classifier model, we have the number of neighbors. So here we are initializing this model with a random k centroids randomly. Then the model will assign each point to the closest centroid. So for example, let's say we had this data here. So these black points that I've shaded there, those are the centroids. So what the model does is, so for example, we've specified our k to be equal to 3. So it will group this data into 3. And what it does is, for each item that we have in this box, so which is the closest centroid that each of the data point is close to. So you can see like the circles that I've created there, it show you where each data point is close to. So these are the centroid. And now after doing that, you compute the new centroid of each cluster by taking the mean of all points assigned to it. So there are some calculations that happen in the backend that will define if this point will be above or below in this circle. So that's how the k-means work. Then the model repeats step 2 and 3 until we have something that's final. So what are the advantages of using k-means? So it's simple and easy to implement, works on large data sets, and it's fast and efficient in terms of computational time. So remember, I've mentioned that the other one is tree-based, and as we saw, so when learning random forest and decision trees, so random forest and decision trees take need more computational power to work. So same for hierarchical clustering, unlike the k-means which works based on distance. So disadvantages, so it's sensitive to initial centroid selection. So if you define the number of k to be equal to 3, and maybe let's say you define in another model your k to be equal to 2. So it means that, for example, these points that we had up there, then this excess that we had down here, and the other class, so these other classes. So what the model will do is it will come up with single centroid for these classes here and a single centroid for these classes here. So your final result will be something like this. So we have that as group 1 and this as group 2. So let's say that's group 1, this is group 2. So you will have 2 classes instead of 3. Okay, so that's the only disadvantage. So the k, there is a way you can determine the optimum value for k, but the k value is mainly based on your intuition and what you want to achieve in the end, because there is no optimum value for k, not unless you define it and maybe you come up with reasons as to why you want to define that specific number of k. Okay, so let's go to the practical part and see how k-means works. So here I will use the IRIS dataset. So I'll create a new notebook and this will be the k-means dataset. So you can launch your Jupyter notebooks and create a new notebook. So what I'll do is I'll start by importing some few libraries. So libraries that we usually use. So we will start by import pandas as pd, then import numpy as np, matplotlib, and then seaborn sns.set. Then we will import warnings, so to ignore all warnings. So that's the code we are using for now. So go ahead and launch your notebooks and import your libraries. Okay, so the second part will be to import the data. So I'll import the iris dataset. So we will have iris being equal to pd.read. So we need to get this data from an online source. So we will have sns.load underscore dataset iris. Then I can check the top 5 rows and confirm if this is the dataset I need. Okay, so I'll have to run this cell that's up there first before running the code for loading the iris dataset. Okay, so here we have the data. So what I want you to do is load the data and confirm you have it on your side. So I'll give you 2 minutes to do that. So make this library importation, then import your data, and then we can go ahead and discuss how we are going to fit a model for this. So we are going to fit an initial random forest model that tries to predict the flower species. So we will use random forest classifier to do that. Then after doing that, we will assume we don't have the species column. And what we will do is we will drop the species column, create a plot, then from that plot fit a k-means model and compare the results of the original data set with what we have in k-means. Okay, so I believe everything should be okay on your side. So let's do a discussion here and see what we are going to do. So we are going to have task. Okay, sorry for that. So we are going to have task one, and task one is to fit a random forest model. Sorry for that. So a random forest model to predict the species of the iris flower using the iris dataset. So that's our task number one. Then task two, so would be to fit a K-means model to cluster the iris dataset. So what's the reason of us doing this? So to see if the model can learn the flowers, the species of the flower without being told the species. So we want to see if unsupervised learning models really work without being able to see what the label is. Okay, so that's what we want to see. So that's our task one, that's our task two. So before we do that, let's create a scatter plot. So we will create a scatter plot of the data with the color indicating the species. So we have to pick two of the columns here. So what I'll do is I can pick sepal length and petal. So sepal length against petal length and use the species column as the color. So we will have something like SNS dot scatter plot, then X the petal length, then Y the petal width, then hue being equal to species, then our data is the iris dataset. Then we can run that. So yeah, let me share this code in the chat section, then we can proceed. And maybe I can explain what we are seeing here. So if you check this data or if you have a look at what we are seeing here, so let me save this image and then maybe we can try draw a few things on the image. So this is our image. So we have three species of flowers. Okay. So if I say I want to maybe draw a few things here, so you can see this should be our first class. Okay, and this is the class Setosa. So I'll mark it with an S. Then here you can see we have our second class of data, which is class versicolor. Then so these plots don't have to be that perfect. Then this is our other cluster, which is class. So this is versicolor and this is virginica. So that's that. And this is the other one. So you can see we have three distinct groups in these data. So we have three distinct species of flowers in this data. So if we ignore the species column and fit a k-means model, so will it be able to generate something similar to this? So actually what we can do is we can start with task 2 because that's the new thing we are learning today. So hope you've written this or you've copied this from what I've shared. But yeah, let's fit the k-means model. So I'll take that slow and I'll explain each and everything I'm doing. So what we will do first here is, so we are going to fit a k-means model. So to fit k-means, you need to import the k-means library. So from sklearn.cluster, since we are doing a clustering task, import k-means. Then what I'm going to do is I'm going to prepare my data. So the first thing we do is we drop the species column. So we will have, so this was data. So we will have k-means underscore data being equal to data dot drop. So I want us to drop the species column and make sure the species column is not there at all. So it should be iris dot drop. Then we drop the species column. Okay. Then we are going to instantiate. So we are going to instantiate k-means model with 3 clusters. And why are we creating 3 clusters? Because already we know that our data set over here has 3 species. So in other data sets that you will be working on, so you won't be able to like know the specific number of clusters you'll need. So it will have to be defined by your problem statement. So for example, if you want to group customers into 4 different groups, so let's say like good performing customers, averagely performing customers and all that, then you'd have to create 4 clusters. So if you wanted to maybe group the customers into only bad and good customers, then you can create only 2 clusters. So basically that's how clustering works. So here we instantiate our k-means model. So k-means being equal to k-means, then number of clusters being equal to 3. Then what we do is we feed the model to these data, so the k-means data. So we will have k-means.feed, then we feed it to the k-means data. Then we create labels from the model. So to get the labels, we type in k-means dot underscore labels. And if we run this, so it's going to take a few seconds to run, and then we are going to get our labels. So let me share this code in the chat with you, give you 3 to 4 minutes to copy it, and then we can proceed. So if we run that, you can see we have some labels here, and the labels are from 0 to 2. So it means we have 3 different distinct labels. So 3 minutes, you copy the code, and then we can proceed. Okay, so I think we can proceed. So already we've seen how we can extract the k-means labels. So what we will do is we will regenerate this plot. So I'll copy everything that is up there and I'll paste it down here. Then for our data, we will use the k-means data because already we know in our k-means data we don't have the species column. Then for hue, I will use the k-means labels and we will get to see if the classes that have been created look similar to what we have up here. So let's run that and see if that's the case. Yeah, so you can see here, this is the plot that has been generated. So actually I can save this again. So this will be our second image. So this will be output 2 and I'll save the plot image. So actually I can move this to the left hand side. Then I'll open output 2 image and then we can compare output 2 with output 1. So let's zoom in and this is what we have. So you can see for output 2 we have class 0, 1 and 2. So these are the different groups that the k-means model has created for us. Okay, and you can see here where we have the class Setosa, you can see these data points are similar to what we have down here, the labels for class 1 that the k-means model has created for us. Then here in the middle where we have the versicolor, we have class 0, which the model has created for us. So you can see for this part where we have these class 0 and 2 connecting together, it's not that much perfect. So the results that we are getting here are not that perfect as compared to the original dataset. And basically, this is where the accuracy issue comes in. So if you want to confirm, so the clustering model won't be 100% accurate, but you can see it's good at creating these classes if you haven't defined them in your data. And basically, that's how you fit a k-means model. So I'll close that and I'll also close that. So any questions concerning the k-means model? So there are a few things I haven't shared with you here in class. So you can go through the notes here and see some of the things I haven't shown you. So the only thing I haven't shown you is getting the coordinates of the cluster centers. But these won't be that much relevant as we only use these for plots that we are getting from the data. Yeah, so that's basically it for the k-means. So let's quickly do task 1, and task 1 will be to feed a random forest model. So this is just a repetition of what we've been doing. So let's do that here. So feed a random forest model. So for random forest model, we will have from sklearn.ensemble import random forest classifier. Then we will have our x being equal to iris.drop, then we drop the species dataset. Then our y should be equal to iris, then we select the species column. So we don't have to do any pre-processing because already the features are all numeric. Then after that, what do we do? So we instantiate our random forest classifier model. So rf should be equal to random forest classifier. Then we feed the model, then we make predictions. So we will have our ypred being equal to rf.predict. Then what we are going to do is we are going to show our classification report. So we will have from sklearn.metrics import classification report. Then we print our classification report. So our classification report will be based off the Y and the YPRED. So let's run that and see what we get. So we get a model that is 100% accurate in predicting all the three classes that we have here. Yeah, so that's all for today. So tomorrow we will look at hierarchical clustering and discuss how hierarchical clustering is different from k-means. Yeah, any questions? Yes, Claire.
Good evening.
Good evening.
I have an issue with K-means
Yeah.
where we're fitting the model to the data.
Yep.
I'm getting an error. If you can kindly scroll up.
So this part here.
Yeah, the fitting the model to the data.
Yep.
The K-means dot fit into bracket K-mean. My key is telling me it is not defined.
Your k-means is not defined.
Yeah.
Okay, so it might be a spelling. So confirm the spelling of k-means data.
My spelling
And
is correct.
yeah, have you imported k-means?
Yeah, I imported the data. So yeah, I did import it.
Okay, maybe can you share your screen? Are you able to share your screen?
Nope. I'm using my phone for the class.
Okay, then. So
What will be the issue? I
let's
tried
start
figuring out.
let's start from line 1. So
Mm-hmm.
confirm you've imported k-means, and k-means, for k-means, K and M are capital letters.
Yeah. Mm-hmm.
Then k-mean underscore data. So we don't have an S at the end of k-mean. So
Okay.
it's just k-mean.
Mm-hmm.
Then we are just generating this data from a subset of the iris data, the data
Mm-hmm.
set that we had imported originally.
Okay.
Then this is the part for instantiating the model. So we have
What is the
k-means,
difference between the two K means?
this one and
No,
this one.
this that one and the
Mhm.
one with capital K and M.
So this is just we are just creating a variable here that
Okay,
will
okay.
store our model details.
Okay.
Yeah, so is this there?
That one is okay.
K means small letter, then this is K means K and M being capital, then open brackets, define the number of clusters.
Mm-hmm.
So n underscore clusters being equal to
Equals
3.
3. Mm-hmm.
That's okay.
Yeah, that's okay. That's fine.
Then k means dot fit, k mean data. That's also fine.
Now that's why I have a problem. Okay. I've seen it. My K was small instead of capital. Thank you.
Okay, then. You are welcome. Anyone with a question concerning what we've covered today? Okay, so if you have no more questions, I think we'll end the session there for today. So thank you for joining.